Hi students, welcome in the chemistry classes. So we are seeing the organic name reaction mechanism. Actually we are seeing the coupling reactions that are from the organometallic compounds. Okay, so we can call them also the organometallic coupling reactions because here the organometallic complex are used as the catalyst. Okay, so a catalytic cycle is being happened here. Okay, and this whole is happening with the organic compounds. So actually it is organic reaction, but we can say them organometallic coupling reactions. Okay, so here we are understanding one of the very important reaction, that is Hiyama coupling reaction. Actually the all reactions that we are seeing here are almost same, okay, because these all are related to the Suzuki coupling reaction that we have seen earlier. So if you want the lecture of the Suzuki coupling reaction, you can find that lecture in the playlist of organic name reaction mechanism. Okay, and if you want a detailed course of inorganic chemistry or physical chemistry or organometallics or anything, you can go to our app and you can see there that courses. Okay, the courses are available with the free PDFs, assignments, tests, etc. Okay, so now we are starting the Hiyama coupling reaction. Actually, it is just like the Suzuki coupling reaction because it is also happening by the palladium catalyst. So it is a palladium catalyzed cross coupling reaction. What is meaning of cross coupling? Means two different molecules are being coupled. The carbon-carbon new bond is formed between two different molecules. Okay, one is the organocellone compound. Okay, and the second one is organic halide. Means the reaction is happening between the any halide or triplet and the organosilicon compound. Means the R group that is attached to the silicon. Okay, this is organosilicon compound R, and to which Si is attached, to which different groups are attached. This is called the organosilicon compound because an organic group is attached to it. Okay, so from here this organic group is being transferred to this organic halide. Okay, this is happening, a new carbon-carbon bond is being formed. Actually, this reaction requires an activating agent. Means actually, it is not happening simultaneously. We need an activating agent like fluoride ion or a base. Base means hydroxide like NaOH. Okay, so we need a base or fluoride ions to activate this. Why? Because without the effect of activating agent, the transmetallation. This is one of the important process in the catalytic cycle. There is happening transmetallation, and about this we have seen in the organometallics. Okay, this is one of the very important organometallic reaction. So transmetallation should be happen, but without activating agent, this is reluctant. So we need an activating agent. Okay, this thing we will see somewhat later. Firstly, see what is the reaction. What is happening here? See here. As I have told you, this is our organosilicon compound. Okay, and this is being reacted with this halide. Okay, and this is happening in the presence of a palladium catalyst. Now, one thing you should remember, that when this catalyst is reacting, the palladium is in zero oxidation state. Okay, this is happening in the presence of a fluoride ion or a base. So what happens? The two bonds are breaking out in this manner. Okay, and this R and R, this are being coupled. A new bond is formed between this R and R. So this is called the coupling reaction. Now this R that you are seeing, this R is either alkenyl group or okay, or aryl group or alkynyl group or alkyl group. Any group this may be. This type of group this is. Okay. And this R dash that is present here, this one, this may be any aryl group or it may be alkyl group or it may be alkenyl group. Okay, so these groups we need. Now what is Y? You are saying this is Y. Actually, this Y is either OR whole thrice. Okay, it may be 3 methyl groups, it may be Me2OH, or it may be Me 3 minus N F N plus 3. Means if one methyl group is present, two fluorides may be present, or one fluoride may be present, two methyls may be present, or all three methyl groups may be present, or all three OR groups may be present in this manner. Just like see here, suppose you have given R, Si, to which three OR groups may be attached in this manner. Okay, this thing can happen. Okay, so it may be present in this form. Okay, and X is a leaving group like Cl, Br, I, OTF, etc. Okay, for example, just see if you have taken this X. Now you can see to X an aryl group is attached. Okay, so this is aryl halide. Now we are taking a organosilicon compound. This aryl group is attached to silicon. Okay, and to it two Cl and one vinyl groups are attached in this manner. Now you are treating them in the presence of palladium catalyst. Okay, this is palladium catalyst and it is treated in the presence of base and fluoride. Okay, so what will happen? Nothing you have to do, just you have to break this bond from here, this bond from here, and what you have to make? You have to make the bond between the two R groups. Means from here you have to attach the new group. It means this one in this manner. Okay, so you are getting your answer. Now this is the just answer. But if you want the mechanism, because if you are preparing for the any detailed course like MSc course, like BSc course, if for anyone, okay, you want a descriptive way, then you should know the mechanism. See here what is happening in the overall catalytic cycle. Actually, we are taking a palladium complex. Okay, generally the palladium complex you all know is square planar. So whenever you take any complex that will be square planar, so it will be tetra coordinated in this manner, but it is inactive form. We cannot use it because it is inactive. It will not take part in the reaction. Why? Because it is having 18 electrons, and whenever any complex is having 18 electrons, it is inactive. It cannot take part in the reaction. So what will happen? We have to remove two PBS3 groups. Now we are getting a bi-coordinated complex in this manner. Okay, this is our complex. Now this complex is having coordination number of 2 and its oxidation state is 0. Palladium is in 0 oxidation state. Okay, and it is 14 electron species. So it can take part in the reaction. So we are starting our reaction with this one. Okay, so we are writing it. We can write it in this manner in a short way so that we can do our catalytic cycle. This is our catalyst. Now it is reacting with the halide. Halide is Rx. When they are adding, what is happening? Oxidation is happening. This is oxidative addition reaction. Means firstly the metal will get oxidized by 2 numbers. The palladium oxidation state will increase by 2 numbers, and secondly there is happening addition. Means these two groups R and X will add to palladium. Okay, so now palladium will become tetra coordinated. So you are getting two ligands trans to each other because Rx is a polar group. Okay, so you are getting this type of tetra coordinated complex. Okay, this is called oxidative addition. Now what will happen? See here, this is our complex. Now we need our another reagent. What was that reagent? See here, this is F3SiR dash. This is our group. Actually this is in inactive form. Why it is in inactive form? Because you can see this is silicon. It is from carbon family and its coordination number can be 4 and it is tetra coordinated. You can see 3 fluorines and 1 R is attached to it. Means it is tetra coordinated, so it is actually inactive. Okay, so firstly we react it with F minus or with a base. So what will happen? Now here this will form F4SiR dash and a negative charge will come here. Now it can give a R dash minus carbon ion. Okay, and this SiF4 will leave out. Okay, this R dash is of our use. Okay, so this was our palladium complex. Now this palladium complex will react with this R. Okay, this R dash group will react with it. Means what is happening? This process is called transmetallation. Transmetallation means when a group, an organic group is being transferred from one metal to another metal, this is called transmetallation. Actually, it is a replacement reaction in which one of the group of palladium is being replaced by the R group. So simply what you have to write, palladium to which two R groups are now attached. Okay, two R groups are now attached and two ligands are attached here. Okay, now you can see these two ligands are in the transposition. Okay, this R and this R are trans to each other and we want to make a bond between them. This is our aim. Okay, but we cannot make a bond. Why? Because these are trans. So they will not form a bond. They need a cis geometry for forming the bond. So there will be cis trans isomerism. So the second step that you are seeing here is the cis-trans isomerism. Okay, as a result of this cis-trans isomerism, what you are getting, this PD, R and R dash will come on the same side. This is L in this manner. Okay, and then this will see here. This will now undergo the reductive elimination process. Means, what is the meaning of reductive elimination? I have separately made the video lectures on the full theory of reductive elimination, oxidative addition, injury migration, all the things. Okay, so if you want that, you can go to our organometallic playlist, and if you want more details, then you can see our app. Okay, full courses you will get here. So now the two groups that are R and R dash will leave out. Okay, means they will form a bond and they will leave out, and we are getting our complex as it is, our catalyst as it is. So this is the whole cycle that is happening. Now you can see the cycle in a detailed way. See here. Now you can see it. Firstly, what is happening? This was your palladium complex that is reacting with this Rx, and this step is called oxidative addition. As a result, a oxidative addition product is formed that is tetra-coordinated. Now this tetra-coordinated complex will react with this silicon. This is actually in inactive form that firstly reacts with chloride and it forms R dash group. That will react with palladium and it will form this type of complex. Okay, this is called the transmetallation. It is the second important process that is happening. Then happens the cis-trans isomerism. So you are getting a cis compound, and then the next important step is the reductive elimination, by which the two R groups bond to each other and leave out the complex. Okay, so you get your catalyst as it is. So this is the whole catalytic cycle that you are seeing. Okay, now I think this will be clear in your mind. So now we come to the examples. Which type of questions are asked? Suppose you have given these two compounds and these are reacting in the presence of a palladium complex. In this manner, you have given a palladium complex. This is seems somewhat complicated. Okay, but you have to see that this is a palladium complex. Okay, and this is in a suitable solvent like BMF, and KF is present as base, 100 degree centigrade temperature you have given. So what will happen? You see that there is a halide present and there is a silicon organosilicon compound. So what you have to do, just you have to break the two bonds. Means silicon is attached from here, means this is our R group. Okay, and iodide is attached from here, so this is our another R group. So now we have to make a bond between them. Okay, so how we will make a bond between them? See here. In this manner, you will make your compound that is written arrow up above the arrow. Okay, so this is our halide group, to which you have to remove the iodide and you have to make a bond in this manner. Okay, and this is S. In this manner you will have to make the compound. Okay, so this is your product. Now see the second example. See here, these are the two compounds that are given to you. Okay, and the reaction is happening in the presence of BU4, NF, PD, OAC whole twice, and you have given PH3P. In the presence of DMF as solvent, you have to reflux it. So these are the conditions for the Hiyama coupling reaction. Okay, so you have to break this bond from here, this bond from here, and you have to make a new bond. Okay, so C5H11 you will write in the same manner. Okay, in the same manner you have to write, and from here you will make the new compound. Means now you have to make this one compound in this manner. You have to make. Okay, so you are getting this one product. Okay, so this is whole about the Hiyama coupling reaction. I think you got clear this whole concept with the examples. These examples I have taken from the reference books. Okay, so this type of examples are asked in the question paper because same questions are copy and pasted from the books. Okay, so we have taken the questions from the reference book, so you can practice these questions and learn this whole concept. All the coupling reactions are almost same that I am telling you. All the reactions are almost same. Okay, so try to do this. Okay, meet you in the next video with some more reactions, some more topics, and if you want any more topic, you can comment me. Okay, for my detailed courses, you can visit our app. Okay, so link is given in the description box. Meet you in the next video. Thank you.